Now we are ready to visualize our decisions and that architectural styles that we will choose. What can we use for this? As you know, one of the most popular is UML and diagrams that consist of different range of unified modeling language consist of different range of diagrams that can be used, but mostly the situation is that nowadays a lot of things are skipped when we are talking about the UML, and some of the diagrams they present in a free way, which then provides the strict view of the system that all of the participants will understand. Sometimes it is the context is not mentioned. Sometimes the legend is not mentioned. Sometimes arrows is not. It's hard to understand what means these arrows, what kind of communication it means, and so on. And one of the possible approach, instead of using the UML, it is proposed by Simon Brown, the C4 model for visualizing software architecture. And this approach includes different levels of presentation. Let's take a look. So C4 model consists of why C4? Because it is consists of system context, it consists containers, components, and code. What means each of these levels of abstraction to visualize the static structure of a software system? The first level, system context, it is a diagram that provides a starting point showing how the software system in scope fit into the world around it. So it means in this level we'll take a look for each of them more detailed, but to be shortly, in this level you shouldn't go into the details inside of the system. You should just to present how your system will interact with external world. Next level, it is each of the level will be more detailed, like we will go from more detailed and more detailed in each of the steps of layers. Next one is containers. So container diagrams zoom into the software system in scope, showing the high-level technical building blocks and how they interact with each other. Next is component. The diagram zooms into the individual container. So we will zoom from one level to another one, showing the component inside it. And for you, it will be enough to stop in the component level. No need to go to the C4 level code. The code, it is mostly UML class diagram, can be used to zoom into individual components, showing how the component is implemented. So such kind of detalization will not be required in your work. It will be enough to cover 3 of these parts. Let's try to visualize and understand what each of these level means on the diagram and what it means zooms and going into details and so on. So here is a picture that shows you each of the level and what it should present. For example, in the level 1 context diagram, you can see that all of the system is mentioned in one block as a system. Then there is external system, actors who will use the system, and so on. This kind of information should be present in level 1 in context diagram. In next diagram, which is called container diagram, you will zoom into the system and you will show the containers which will include into your system, web container, API application, and so on. So each of the container, it means something that is that it can be deployable separately, or in generally that is passed. If you will choose the distributed architecture style, so it is wrapped by the container. Next, you can zoom in into each of the containers and see the components levels. What means components levels? It is something intermediate between the exactly the classes and containers. So you will take, let's imagine that we choose the microservice architecture. You will see here different services. Then if we'll zoom in into each of the service, you have to represent on your diagram what will be inside of your service. What kind of component. Doesn't mean that you have to put here all classes at all. No, not at all. But you can put, or you can represent that you will have, for example, a service layer, presentation layer, persistence layer of some of the domains area, something like this. And next will be level number 4, which will represent the code level of detailization. So you can think of C4 diagram as being a set of maps for software system, which provides you with the ability to zoom in and out in varying levels of detail. So it should be reading from up to down. It is proposed in this way. First one, it will be most general system context and containers, the system plus users and system dependencies. This is a system context. Containers, the overall shape of the architecture and technology choices. So here in the containers, you have to present which kind of technology you will choose. Then you can zoom in into each of the container and represent what will be inside of containers by the components. Components and their interaction with the containers. So other containers, if they interact with, also should be present. If it is necessary, then you can zoom into the component and show what kind of classes, how this component will be implemented. Let's take a look for the examples. Here is the level 1 system context diagram. So the system context diagram can be useful a starting point for diagramming and documenting the software system, allowing you to step back and look at the big picture. And this diagram is mostly will be actual for top management, or they don't need to go into the technical details. They want to see the big picture to understand how your system will interact with other systems who will use this system and so on. Pay attention how this diagram looks like. The gray blocks is external block systems. So it means this is quite well structurized diagram. It means that you are not allowed to maybe you allow it, but it is not expected that, for example, external blocks will have the green color or orange color or something like this. So it means in C4 diagram, in most cases, external system will be mentioned as a gray color. Your system will be as I suppose this is a blue color, and here is the name of your system. Then you have to mention what it is. For example, here is a person, and this is a software system, and short description what this system will do. Pay attention that all communication should also there should be explanation and description what each of the error means, what it means, and what kind of functionality it provides in terms of verbs. So, for example, view account and balance, send email, get account, and so on. This is the C1 level diagram. So elements. Elements in this system, in a system context diagram, usually includes two types of elements. It's people and software system, nothing else. Interactions. Try to annotate every interaction between elements of the diagram with some information about the purpose of this interaction. So it should be readable and other person should understand what you are meaning with this interaction. When you put some error from one block to another to represent the interaction, please add the description. Audience. Technical and non-technical people inside and outside of the immediate software development team. So yeah, this is general diagram. Everyone should understand it. It's as easy as possible. No need to have technical skills and so on to read this diagram. Required or optional. All software systems should have a system context diagram. This is a required diagram. It's not optional at all. Next level is container diagram. The container diagram shows a high-level shape of software architecture and how responsibilities are distributed across it. It also shows the major technology choices and how they are used and how containers communicate with each other. So you can see that we zoom in into our system. There is still the person, the actor who will use, for example, banking, a personal banking customer. We mentioned this is a person and have a description, the customer of the bank with personal bank account. Then we still have um, external system that will communicate, but in this case, not as it is mentioned here with internal banking system. So but with the components that will be inside of this system. So we zoom in this block and show that this internal system will include next components, next containers: web application container, single web application, mobile application, API application. Each of these container, it's mentioned here that container is used some of the technologies. For example, this one will be built based on JavaScript and Angular. Mobile application will use Xamarin. Here we use web application that it will be built using the Java and Spring MVC, and so on. So you should point what kind of technologies are used for each of the containers and provide some description about the functionality. For example, this one provides internet banking functionality via JSON and HTTP API. And as you can mention, this technology's communication is also mentioned here in the description of the arrow. So pay attention for this. They should be present for each communication. We should understand what kind of technology you will use here: HTTPS, SMTP, JSON, and so on, and also what the action it is required, what they will do. Of course, it can be you can have let's say 10 times communication between each of the container. No need to put all of them, just only one communication, and highlight the main things. Why this container should communicate with other container. When you will start your practicing, you can face with next things. Please remember it. So you can think, okay, I don't actually understand what the container is. How many containers I should build? How should I can put 3, I can put 5. What it is general container. To make the life more easily, you can think about the container as a separate container image, something that is deployed separately. For example, as for microservices, a separate service is wrapped into the Docker image, and it can be deployed separately from other services. Something that can be run independently from others. It will make it should help you to understand and make a decision how many containers you will have and how they will interact with each other. Elements. So container diagram usually includes 3 types of elements: people, software systems, and containers by itself. Interactions. Typically, communication between containers is out of process between the containers. It's very useful to explicitly identify this and summarize how this interaction will work. Audience: technical people inside and outside of the immediate software development team, including everybody from software developers through the operational and support staff. So they also should know how many containers. DevOps, for example, they should know how many containers they will have, how the communication will be implemented. So for each of the container, they will prepare the infrastructure, pipelines, and so on. Required or optional: all software systems should have the container diagram. This is required. This is not optional. We have to understand how many containers we will have, how they will communicate with each other and the external system. Level 3, component diagram. So we will now zoom into one of the containers, into one of the service, let's say. Component diagram show the component that reside with a single container at time. So here you can see we still have different containers. So we don't have here actors, we don't have here external components, but we have here other containers inside of our system. And in this boundary, it is mentioned what it is inside of this container. The color is a little bit different. It is you can see that this blue is different from this one, is more lighter, I would say. And you will try to represent inside of, here is a, by the way, the border that is mentioned, this API application container that will work with this database, and here you will represent your components and interaction with these components by each other. Also put the connection, will this component use or make some calls or something like this. Here is an example. For example, uh, sorry, yeah, sign-in controller, security component, email component, reset password component, account summary controller, and so on. It can be built based on the domain, or it can be built based on the levels. It depends from architectural style that you will choose. Uh, yes, so the elements. The component diagram can include 4 types of elements: people, software system, containers, components. So yeah, please pay attention here. People are also mentioned here. So it means if you want, you can add here, as it was mentioned in the level 1 in the system diagram, the people. But it is not mandatory, and generally the other containers will be enough. Interactions. Typical communication between containers is out of process. It's sorry, it's this is some mistake. So this is taking this is exactly the same as it is mentioned in container diagram. I will tell you what will be the interaction, audience, and is it required or optional for component diagram. So interaction. The interaction should include the purpose of the interaction and communication style. So here you have to represent, is it synchronous or asynchronous for communication style. It will be enough, I believe, and also maybe the purpose of the interaction. So it means you already mentioned on the image, is it uses, is it persist data using, is it delegates, and so on. What is the audience? It is technical people within the software development team. So audience, this one is not correct. Please pay attention. The audience is only technical people. Non-technical people is not needed to be involved for such a kind of diagram. Is it required or optional diagram? This is the point that I would say that it will be for the technical people, it's better to implement. Sometimes it is not required for top management people, but mostly more required, I would say. But the next one, level 4, we will not consider it. It is code level diagram that mostly used UML for level for this, like a class diagram. That one is optional, completely optional diagram, because maybe you will never finish representing such kind of detailization diagram as should be for the UML. So it depends. Sometimes it is required, sometimes it's not, sometimes it makes sense, sometimes it doesn't make sense. But for the component diagram, I would say, at least in your practical world, I will expect that you will present it. Generally, that's all that you should know to complete your next task.